All right, on to the female reproductive hormones. So unfortunately for you, the females are more complicated. There's probably a joke there. I'm gonna leave that. So let's take a look at this cross-section of the ovary in more detail. In particular, I want us to look at this primary follicle here. Now, you'll notice that you have almost like two layers here. And we have what's called the oocyte in here. That's just an immature name. It's the name for the immature egg. And then around it we have these sort of other cells. So we have our oocyte, which is our primary immature egg, and then we also have these cells. These cells are called granulosa cells. And it's kind of like if you think about a chicken egg. You have the egg yolk, and you also have the egg white. And so the granulosa cells, their job is to provide nutrients to the oocyte that is maturing. Now, I want to move on to another thing. So what you can see as we move from stage 1, stage 2, stage 3, and stage 4, and so on, at stage 4 we start to see, well, it begins at stage 3, but at stage 4 we see this sort of almost like a vacuole sort of forming, and that is basically just this fluid-filled section that forms within the maturing follicle. Eventually, and it's called the antrum, and eventually that results in, it bursts, it gets so large that it bursts, and that results in the release of the mature ovum. And that's actually what happens every month for women when they go through their menstrual cycle. Now, I want you to pay attention now to what remains after the ovum is ejected. You have these cells that still sort of remain, and they form into what's called the corpus luteum. And the corpus luteum is going to play an important part in the development and secretion of some other hormones associated with female reproduction. So again, we've got our granulosa cells that are providing nutrients to our developing and immature egg called the oocyte. We have the antrum, which is this fluid-filled interior that eventually bursts and releases, at ovulation, releases that mature egg. And that results in what remains, which is called the corpus luteum, involved in hormone secretion. Okay, so here's the information you need. So, ovaries are going to contain 400,000 follicles. They're going to be immature, and they're going to mature. One is going to mature each month and be released by the ovary. So at this point, this is where I want to juxtapose, and I'm not in great detail, but I want to remind you of some details from grade 11. You'll remember that when you have a diploid spermatogonium, and that's just immature diploid cell, when it divides, eventually you end up at the end of the line, you end up with 4 haploid sperm cells. But if we're talking about the oogonium, that's the immature sort of primary egg, eventually it divides and you end up with 4 pieces, but 3 of those pieces are called polar bodies, and they're not really used in reproduction and can't be fertilized, so you end up with 1 mature ovum. So we get, for every 1 diploid immature cell, we end up with 1 mature haploid cell. And that will happen at the beginning of puberty all the way up until menopause is reached for a woman. And at that point, at menopause, that is where we no longer are seeing these eggs mature properly, and there's a huge drop in hormone production, and menstruation is halted. Okay, so in case you wanted to get a few of those other notes down relating to the antrum and the corpus luteum, here it is. Okay, so the human female menstrual cycle, it can be broken down into 4 stages, and some of them sort of overlap, so but we'll take a look at that. But the total time for one complete menstrual cycle is 28 days. So I've got a couple of diagrams here to help you understand a little bit of the initial ideas. So the first stage begins with the menstrual phase, or the flow phase, which it's called. And so if you look at this diagram, you can see that's the point where what's really happening when a woman menstruates is that endometrium ends up being, well, basically the uterus contracts so much that the endometrium ends up being released from the walls of the uterus and then flows through and out the vagina. So the second phase of that, so basically that's what the menstrual cycle begins with. That is considered day one. If you look over here on the second diagram, you can see that day one begins the first day of menstruation. And so menstruation for women, the period of time the woman will menstruate will vary from woman to woman. Some people will be very light and last maybe 3 days instead of 5. Other women will last up to 1 or 2 weeks, depending, and be quite heavy. But we're going to start the clock at the first day of menstruation here. So after that, and the reason that menstruation happens is because the egg that was released in the month during that cycle, in the cycle before, is not fertilized, and so, but I'll get to the details of that. So moving on to stage 2, the follicular phase. That's the phase where we're going to see that egg mature and eventually get ready to be released into the fallopian tube. And so the follicular phase is we're going to see a few different things happen. If you look closely at this diagram, what would have been sort of an empty, like no endometrium lined uterus, the endometrium is going to start to thicken. So there's just a slight red line here, indicating that the endometrium is going to begin to thicken. And over a period of a few days, as the egg is maturing, the endometrium will get to a point, it will get thicker and thicker. So ovulation is typically said to happen on the 14th day. So remember, this is a 28-day cycle, so ovulation happens on the 14th day after menstruation begins. But again, that is sort of like in an ideal situation and can vary from woman to woman fairly, to a huge extent, but usually is within 12 to 16 days within the cycle. So the ovulation phase is really, we just tend to think of it as the 14th day, but it goes there's a bit of a buffer zone on each side. And that's the point where the ovary, it has released that egg out into the fallopian tube. All right, so looking at about 19 days into the cycle, we are at the point where we start to begin to call it the luteal phase. And so the luteal phase, what you'll see is, the endometrium is quite thick. What we can't see in this diagram is that the corpus luteum, which is what remains after the egg has been released into the fallopian tube, that corpus luteum is also maturing and beginning to secrete some fairly significant hormones. And so depending on whether this egg that was released on day 14 or so is fertilized, the menstrual phase will occur, and if the egg is fertilized, then menstruation will be halted, and that endometrium will stay in place to nourish and support that growing zygote. So in case you're interested in writing some of these details down, here they are: the menstrual or the flow phase, follicular phase, ovulatory phase, and the luteal phase. All right, so for female humans, there are 5 hormones that we need to be concerned about. And we'll hit on them, and a few of them we have in common with the male counterparts. So let's start with progesterone and estrogen. So those estrogen tends to be the one we most associate with female hormones and reproductive hormones. And estrogen is, like testosterone, estrogen is responsible for secondary sex characteristics in females, like breast growth and body hair and body oils. and so on and so forth. Women's voices actually do deepen at puberty. It's just that it's not to the same extent as men, which is why it's almost unnoticeable, but it does happen. So let's take a look at progesterone and its effects. So progesterone its job is to stimulate that endometrium development. In other words, to get it to thicken. And so if we look at these, comparing day 1 of the menstrual cycle, and sometimes this is called the uterine cycle because we're dealing specifically with the uterus. And then here we are at day 28, just to give you a frame of reference. So on day 1, remember that's when your endometrium is going to be a little bit thicker. Well, it's going to be at its thickest in the cycle. And given an unfertilized egg, that menstrual blood, the endometrium, will be released, and that will result in the menstrual blood. And so our endometrium is going to be, at that point, prepare for the release of a new egg and potential fertilization. So at that point, you see these progesterone levels fairly low until day 14, and that makes sense. What's happening day 14? Ovulation. So at that point, the endometrium needs to start to get thicker again in preparation for possible implanting of a fertilized egg. So progesterone is released at, starts to get secreted in higher amounts, close to ovulation, just after ovulation. And that uterine lining will thicken and mature up to the point where the egg sort of starts to reach the uterus through the fallopian tubes. Now, you'll also notice that estrogen spikes at ovulation, and we're going to talk about that in a minute. So another thing that's important to mention and worth noting about progesterone and its role as a reproductive hormone in women is that it also prevents further ovulation, and it also prevents uterine contractions. So I want to talk about that. Let's make sense of that. So if we're looking at the endometrium being thickened in preparation for the implantation of a fertilized egg, then we want to make sure that there isn't another egg being released from the ovary and potentially being fertilized. The more eggs that there are, fertilized eggs that require support and nutrition from an endometrium, the harder it is for a woman to kind of supply that and make sure that all of the offspring are healthy and viable. So progesterone is going to prevent further ovulation to ensure that that initial fertilized egg gets the best conditions possible for growth and development. We also don't want the uterine to contract if, in fact, there's an egg that is fertilized because, well, the whole point of the endometrium is to sort of provide that nutrient base for that growing and developing zygote, right? So we don't want the uterine to contract and shed that endometrium lining because it's what's providing support to that fertilized egg. However, if that egg is not fertilized and arrives at the uterus, then that's where we see over here this drop in estrogen and progesterone levels. And that drop in those hormone levels are what are going to stimulate this the uterus to contract. And it's what women feel as cramping. It can be quite difficult and painful for many women. But those contractions are what sort of start to get the endometrium to start to separate and all that sort of vascular tissue to separate from the wall of the uterus and be shed. All right, so let's look at this as a bit of a feedback loop. And so we're going to see some of the hormones from the male reproductive system kind of come back. I think this is a good place to kind of say, well, what happens with women, what happens with men? They have similar hormones, but the end result is a little bit different. So you'll remember in the male reproductive system that at puberty, the hypothalamus is going to release GnRH. That's going to signal our pituitary gland to release luteinizing hormone and follicle stimulating hormone. So that results in testosterone being produced in the testis, and that initiates some of the maturation of, the LH is going to cause a release of testosterone, and our FSH is going to cause the maturation of the sperm, right? And testosterone is going to go back and signal this process to stop when testosterone levels are sort of reach that set point. Now, if we look at for females and the female reproductive system, we have the same situation happening at the beginning. GnRH at puberty is going to be released from the hypothalamus. It's going to signal to the pituitary to also release LH and FSH. But the results of LH and FSH will be similar, but the hormones will be different. So luteinizing hormone is going to be responsible for thickening up the endometrium. And FSH is still follicle stimulating hormone. It's going to stimulate the maturation of that immature egg. So LH is going to be released, and that's going to so let's put a little bit of this together in this diagram. I love this diagram because it shows us the timeline here on the bottom of the entire cycle, right? So here's 0 days, and then here's 28 days. And so really this section is where we're going to see the whole process start over again. It's just like it's a cycle. So up here we see the ovarian cycle. An ovarian cycle just describes the maturing of the egg and the production of the development of the corpus luteum. We have body temperature. We haven't really discussed that because it's not really related to hormones, but you can see that definitely at ovulation, temperature spikes, body temperature spikes just slightly, and so some people actually use that if they're sort of doing some natural family planning to know when ovulation is happening. We see here what's going on with the pituitary gland, right? Here's our LH and FSH, which are released by the pituitary. And we see our ovarian hormones, and I'm going to get to that. We've talked about estrogen. Estradiol is a type of estrogen, and progesterone. And so what I haven't mentioned to you is where the heck they're being secreted from, and so that I will talk about in the next little section. And then over here we have the uterine cycle, which just basically shows from a graphical point of view the thickness of the uterine wall or the endometrium. So, all right. Getting back to over here, we see the anterior pituitary hormones, right? So we'll see that at ovulation, our FSH, our follicle stimulating hormone, seems to spike. And that makes sense because if we look at when it's spiking at day 14. That should make sense to you because that is the day where the ovary is going to release that egg. At the same time, we see our LH level spike, and so that's signaling to our endometrium to begin to thicken. And so let's take a look at our ovarian hormones and how that's sort of working at the same phase based on their function. So notice my estrogen here is spiking just before ovulation. So estrogen is very closely related to ovulation. And we'll write some details about that later. Remember progesterone? Progesterone was involved in the thickening of the endometrium wall as well, and so it is going to spike as the endometrium is thickening. Now, but where are these guys coming from? Well, remember that corpus luteum, that body, that structure that results once ovulation occurs. Well, it's maturing and growing, and it's still there. And in fact, once the egg is released, that's where estrogen and progesterone are being secreted from, the corpus luteum. So our high estrogen level right here that we see peaking right before ovulation is what sort of initiates or signals to our LH to rise suddenly. And the rise in our LH is going to help with ovulation. At that point, my high level of estrogen and LH are what are going to result in my FSH being inhibited. Remember, FSH, we don't want any other fertilized eggs, or any other eggs for that matter, to be released from the ovary and to be fertilized, because then we'd have a greater number of eggs possibly being growing in one uterus, and that does not make it great for the first egg that came out. Okay, so as I mentioned, our corpus luteum, once ovulation happens on day 14, our corpus luteum is going to secrete some estrogen and some progesterone, and that is going to cause further development of that endometrium. Okay, and so the release of the estrogen and progesterone is going to have the effect of further inhibiting the FSH and LH, and that's going to cause the corpus luteum to start to break down, because again, as the cycle repeats itself, there'll be a new corpus luteum available to secrete estrogen and progesterone. We want to control how much is being secreted, so the corpus luteum from a particular cycle has to degrade before another cycle begins. Once the corpus luteum deteriorates, obviously it's not going to be there to be secreting any estrogen or progesterone levels. So their level of production is going to drop, and that's going to cause the endometrium to no longer be sustainable, and it's going to degrade, and that's when menstruation begins. So I can certainly appreciate that that's a lot of info, and we should definitely go over this when and if we get together as a class. Feel free to jot down some questions, and I will do my best to answer them tomorrow in class.